When a mercury thermometer and an alcohol thermometer are used to find the temperature of a substance, they may not show the same temperature readings. This is because the thermal properties of different substances are different, and the rate of expansion of a substance changes with temperature. That means the per degree expansion of a liquid is not uniform at all temperatures. The readings shown by different thermometers may coincide at calibration points, but may vary at other temperatures. Due to this, these thermometers are of no use when accurate measurement of temperature is needed. It is experimentally observed that the temperature readings of gas thermometers are independent of the gas used. Hence, these are more reliable for the accurate measurement of temperature. A gas thermometer works on the basis of variation in the pressure or volume with the temperature of the gas in it. Boyle's law states that if the temperature of a given mass of gas is constant, then its pressure is inversely proportional to its volume. At constant temperature T, PV is equal to constant, where P is the pressure of the gas and V is the volume of the gas. According to Charles' law, at constant pressure, the volume of a given mass of gas is directly proportional to its temperature T. Therefore, V by T is constant. On combining equations 1 and 2, we get PV by T is equal to constant. This is known as ideal gas law. PV is equal to mu RT is a generalized ideal gas equation, where mu is the number of moles of gas and R is 8.31 joule per mole per Kelvin, which is the universal gas constant. The constant volume gas thermometer works on the principle of the ideal gas law. Since PV is directly proportional to T, when the volume of a given sample of gas is constant, its pressure changes linearly with the temperature of the gas. When a graph is plotted between pressure and temperature, a straight line is obtained. If the density of the gas is low, the graph will be a perfect straight line for all gases over a large temperature range. Let's look at the pressure-temperature graph for different gases at low density. When extended towards negative temperatures, all these straight lines meet at a point represented by the temperature minus 273.15 degrees centigrade. That means, at temperature minus 273.15 degrees centigrade, if the gas is still in the same state, its pressure reduces to zero. In fact, at this temperature, the average kinetic energy of gas molecules becomes zero. As a result, they cease to move and settle at the bottom of the container, and the pressure exerted by them reduces to zero. A new temperature scale was developed by Lord Kelvin by designating this temperature of minus 273.15 degrees centigrade as zero. This new temperature scale is known as the Kelvin or absolute temperature scale. The zero of this scale is called absolute zero. The temperature of a body on the absolute scale is expressed in Kelvin and is called absolute temperature and is represented by the letter T. The size of a degree on the Kelvin scale is identical to the size of a degree on the Celsius scale. For example, if the temperature of a body is increased by 1 degree centigrade, then the corresponding change on the absolute scale is 1 Kelvin. The relation between the absolute temperature and Celsius temperature is expressed as T and is equal to Tc plus 273.15. Here is a comparison between the Kelvin, Celsius and the Fahrenheit temperature scales.